This is radium, a highly radioactive element once celebrated for its mysterious glow and medical potential, used in everything from cancer treatments to glow-in-the-dark paints. Yet radium is incredibly dangerous, even deadly to touch. So how was it discovered? The story of radium is the story of two extraordinary minds, Pierre and Marie Curie, a husband and wife team who pursued this discovery with relentless passion and unimaginable sacrifice. But this documentary focuses on the lesser-known half of this iconic duo, Pierre Curie. His contributions, often overshadowed, were crucial to their breakthroughs, achievements that came at great personal cost. This is Pierre's story. Pierre Curie was born on May 15, 1859, in Paris, France. He was raised in a lower middle-class family with limited financial resources. Pierre shared a close bond with his older brother Jacques, who would also pursue a career in physics. Their mother, Sophie Claire Depuy, and their father, Eugène Curie, a physician, influenced their early development. During this period, formal education was not mandatory, so Pierre received his early education at home. Demonstrating a passion and talent for mathematics, he was trained by his father in this subject, as Eugène believed that private tutoring would best cultivate his son's intellectual potential. At the age of 16, Pierre began his university studies at the Sorbonne in Paris. He earned his licentiateship in physics in 1878 at just 19 years old, which is comparable to a master's degree in the United States. Due to financial constraints, he was unable to pursue his doctoral studies immediately. Instead, Curie took on the role of a poorly compensated laboratory instructor until 1882, when he was appointed to oversee all practical work in the School of Physics and Industrial Chemistry. Pierre began his career with his older brother, Jacques, conducting pioneering research in crystallography. In 1880, the two discovered the piezoelectric effect, where certain crystals, such as quartz, generate an electric charge when compressed. This breakthrough led them to create the piezoelectric quartz electrometer, a tool for measuring faint electric currents that would prove crucial in scientific research for years to come. When his brother took a position as a professor, their collaboration stopped, and Pierre shifted his focus to studying magnetism. In his work, he uncovered a key relationship between temperature and magnetism. Certain materials lose their magnetic properties at a specific temperature, now known as the Curie point. This finding not only advanced the understanding of magnetism, but also laid the groundwork for modern materials science and the study of phase transitions. This discovery, along with his carefully designed instruments, became the subject of his 1895 doctoral thesis, earning him his Doctor of Science degree and a post as a professor of physics at the EMCI. He would later become a physics instructor at the Sorbonne, which allowed him to share his expertise with a new generation of students while continuing his research. Shortly after earning his doctorate, Pierre married Marie Skłodowska on July 26, 1895. Marie, who was 8 years younger than Pierre, was the daughter of a secondary school teacher from Warsaw, Poland. They met in 1894 when Marie, who was then a physics student at the Sorbonne, was introduced to Pierre while seeking a laboratory to conduct her research. They were married at the town hall in Sceaux, where Pierre's parents lived. As a wedding gift, they received money that they used to buy bicycles for themselves, which led to long and sometimes adventurous bike rides that became their way to relax. Otherwise, their life was quiet and routine, focused mainly on work and study. In 1896, a significant development occurred when Henri Becquerel discovered radioactivity, a phenomenon that would profoundly influence the future work of the Curies. Becquerel found that uranium salts emitted rays that could penetrate opaque paper and fog photographic plates. This phenomenon fascinated Marie, who was seeking a topic for her doctoral research. Marie decided to make a systematic investigation of the mysterious uranium rays. By 1897, shortly after the discovery of radioactivity, Pierre joined Marie in her research, as she was convinced she was on the verge of discovering a new element. She tested various materials and found that pitchblende, a uranium-rich mineral, emitted significantly stronger rays than pure uranium, suggesting it contained unknown elements. This discovery led Pierre and Marie to painstakingly process tons of pitchblende to isolate the source of this intense radioactivity. Through their extensive research, Pierre and Marie Curie successfully isolated polonium and radium in 1898. Marie named polonium in honor of her native country, Poland, while the name radium was inspired by the Latin word radius, meaning ray, to reflect the element's intense glow and radiation. Following their discoveries, the Curies agreed on a division of labor. Pierre focused on investigating the properties of radium, while Marie conducted chemical experiments aimed at preparing pure compounds. It was during this time that Pierre, along with a student, observed that a speck of radium spontaneously and continuously emitted heat, marking the discovery of what is now known as nuclear energy. He was also among the first, along with his collaborators, to report on the decay of radioactive materials and the skin burns that radioactive substances can cause. Pierre's invention, the piezoelectric quartz electrometer, which measures faint electric charges, enabled the precise detection of the radiation emitted by these materials, helping them accurately study and quantify radioactivity. As their groundbreaking research progressed, the demands of their work grew. They labored under difficult conditions with barely adequate laboratory facilities and the stress of needing to teach in order to earn a living. Recognizing their need for more space, the principal of the school where Pierre worked came to their aid, offering them a large shed that was not occupied. It was there that the laborious work of separation and analysis began. Marie carried out the chemical separations, while Pierre undertook the measurements after each successive step. Wilhelm Ostwald, a highly respected German chemist, who was one of the first to recognize the importance of the Curies' research, traveled from Berlin to Paris in 1899 to see how they worked. However, neither Pierre nor Marie was at home. Ostwald wrote, "At my earnest request, I was shown the laboratory where radium had been discovered shortly before. It was a cross between a stable and a potato shed, and if I had not seen the work table and items of chemical apparatus, I would have thought that I was being played a practical joke." Ostwald's astonishment at the Curies' humble laboratory highlighted the modest and challenging circumstances under which their pioneering work was conducted. Despite these conditions, the Curies' discovery of polonium and radium formed the basis for much of the subsequent research in nuclear physics and chemistry. Their groundbreaking work in radioactivity garnered significant recognition, leading to the award of the Davy Medal of the Royal Society of London on June 30, 1903. Later that year, on July 14, 1903, Paul Appel, the Dean of the Faculty of Sciences at the Sorbonne, proposed that Pierre be nominated for the prestigious Legion of Honor. Pierre replied, "I do not feel the slightest need of being decorated, but I am in the greatest need of a laboratory." Although he was appointed to a chair at the Sorbonne in 1904 with the promise of a laboratory, he was only provided access to a few rooms in a building utilized by young medical students. Consequently, Pierre never obtained a proper laboratory for his research. Despite this, Marie and Pierre Curie continued to garner further recognition and were jointly awarded half of the Nobel Prize in Physics later in 1903. The citation acknowledged the extraordinary services they have rendered by their joint researches on the radiation phenomena discovered by Professor Henri Becquerel. The other half of the prize was awarded to Henri Becquerel for his discovery of spontaneous radioactivity. In a letter to the Swedish Academy of Sciences, Pierre explained that neither he nor Marie could attend the award ceremony in Stockholm due to their teaching commitments. He stated, "Madame Curie has been ill this summer and is not yet completely recovered," which was indeed true, though Pierre's own health was also declining. As their recognition in the scientific community grew, Pierre's contributions were further acknowledged in March 1905 when he was elected to the Academy of Sciences, solidifying his standing in the fields of physics and chemistry. Shortly thereafter, in June 1905, Pierre Curie was invited to present their research at the Royal Institution in London, where he and Marie gained international recognition. Before a crowded auditorium, Pierre demonstrated how radium quickly affected photographic plates wrapped in paper, and how the substance emitted heat. In the semi-darkness, he showcased the remarkable light effects produced by radium. He shared results from his self-experiments showing the lasting scars radium caused on his skin and suggested its potential in cancer treatment. His scarred, trembling hands accidentally spilled some of the precious radium, leaving traces of radioactivity that 50 years later required cleanup of the premises. In reality, Pierre was ill. His legs trembled so much that at times he found it difficult to stand upright, and he experienced considerable pain. After consulting a doctor, he was diagnosed with neurasthenia and prescribed strychnine. Meanwhile, the skin on Marie's fingers was cracked and scarred, and both of them endured constant fatigue. They were unaware of the harmful effects that radiation could have on their overall health. Pierre often claimed that radium had a radioactivity 1,000,000 times stronger than uranium, frequently carrying a sample in his waistcoat pocket to show his friends. Marie kept a small amount of radium salt by her bed, enchanted by its glow in the darkness. The papers they left behind exhibit significant radioactivity. Today, if one wishes to consult the 3 black notebooks containing their work from December 1897 and the subsequent 3 years at the Bibliothèque Nationale, a certificate must be signed, acknowledging that it is done at one's own risk. This precaution will likely be necessary for a long time, as it takes 1,620 years for the radioactivity of radium to reduce by half. Recognizing the potential of radium in medicine, factories began to emerge in the United States for its large-scale production. A discussion arose regarding whether Marie and Pierre should apply for a patent for their production process, but both were firmly opposed to the idea. They believed that pure research should be conducted for its own sake, free from the influence of industrial profit motives. Researchers, in their view, should be impartial and ensure that their findings are accessible to all. In line with this philosophy, Marie and Pierre generously supplied their fellow researchers with the preparations they had painstakingly produced. They also provided the industry with detailed descriptions of the production process. Radium, once celebrated as a wonder element, has found lasting, specialized roles in modern science and industry. Initially used in cancer treatments like brachytherapy, radium has been largely replaced by safer alternatives, including iodine-125, cesium-137, and iridium-192. However, radium continues to be used in industrial radiography for non-destructive testing, particularly in fields like aerospace, where it enables detailed inspection of engine components and airframes for hidden defects. The Curies' groundbreaking research on radioactivity was pivotal, laying the foundation for both medical and industrial applications, and highlighting how their discoveries, despite radium's risks, paved the way for significant advancements in science and health. Tragically, on April 19, 1906, Pierre slipped on the wet ground, soaked from the rain, on the Rue Dauphine in Paris and fell. A horse-drawn cart then rolled over him, crushing his head and resulting in his instant death. He was only 46 years old at the time of his passing, leaving behind his wife Marie and their 2 daughters, Irene, born in 1897, and Eve, born in 1904. Marie was devastated by her husband's death, but she was determined to honor him in any way she could. As part of this commitment, she took over his position as a professor at the Sorbonne, making history as the first woman professor at the university. However, Marie never forgave France for what she viewed as its disrespectful treatment of Pierre, believing he had been denied the honors and laboratory resources he truly deserved. Motivated by this, she devoted the rest of her life to establishing a world-class laboratory as a tribute to her late husband. Tragically, Marie Curie passed away 28 years later, a victim of the excessive radiation exposure she had endured throughout her groundbreaking research. Pierre Curie was initially buried in a family plot, and Marie joined him after her passing in 1934. However, in 1995, their remains were exhumed and reinterred in the Panthéon in Paris, which is often regarded as the Westminster Abbey of France for distinguished burials. Both Pierre and Marie were enshrined in the crypt of the Panthéon, honoring their remarkable contributions to science and their lasting legacy. As we reflect on Pierre Curie's life, we see a man whose relentless pursuit of knowledge was marked by both triumph and tragedy. Despite the hardships he faced, struggling for adequate resources and dealing with health issues, his commitment to science remained strong. His dedication to discovery led to monumental achievements alongside Marie that would forever change the fields of physics and medicine.